Welcome to the tutorial for using Jupyter Notebooks with dashDB Local and its integrated Apache Spark. So in this video we are focusing on the interactive usage of Apache Spark in dashDB Local, which is something that typically analytic type users such as data scientists would conduct. So our goal is to use Apache Spark and its scalable framework and libraries in order to create such an interactive notebook with visual elements that we can see here in order to analyze and visualize insights and data in dashDB. While the Apache Spark is part of dashDB local container itself, the notebook server is not, but it comes to you as a ready-to-run container setup that you can create and set up yourself by going to this GitHub project. It contains two subfolders for two different containers for dashDB, one for RStudio and one for notebooks with Jupyter, both ready to run and optimized for use with dashDB. Go to the dashDB local notebooks folder, and there you'll find all the needed steps that you need to run on the Docker host environment in order to set up the notebook container in addition to your dashDB local container. You will see it's not that complicated. Let me briefly walk you through these steps. We start with cloning the Git repository in the Docker host environment, as you can see it here. Next, we enter the same subdirectory for the notebooks itself again on the command line, and from there you can now, as the documentation describes, run the docker build command in order to build your notebook image on your Docker host. So we are now running exactly this build command, and it'll take a little while until the image is built, and when done we consult the documentation again, and here we can find the command to start up and run the notebook container. You should run one container for each different user that you want to give access to notebooks with your dashDB local container. You specify the user and password to use with according variables that you pass to the docker run command as shown here. Now checking the log output of the container, you see it starts up pretty quickly and it gives you information where under which port you find the new notebook server on the Docker host. It's exactly the same kind of information that also documentation points you to. So let's open a browser on that port and let's see what's there. And it gives us the standard Jupyter user interface with one little sample notebook that we provide out of the box. And you can see that we have special dashDB kernels for Python and Scala that you can use to interactively work with the integrated Spark cluster in dashDB. For the sake of this tutorial, I have already created a little demo notebook that I'm opening now, which uses some Spark machine learning algorithm. I'm quickly executing those cells that are for preparation and some data loading and data preparation for the demo to get to the interesting part. And this is creating a data frame based on a dashDB table. We are using actually the standard Spark SQL context mechanisms in order to read a data frame, just with a little difference that we're using a special data source, the so-called IDAX data source. IDAX stands for IBM Database Analytic Extensions. Now we also only specify the table name, and this is all what this data source needs in order to load the table into Spark in a very optimized way inside dashDB local. The specific dashDB system I'm using here is a single node system, so the data is not partitioned yet. So I'm just using Spark in order to create a partitioned data frame in order to leverage all the parallelity that Spark provides to me. Next, I'm using the standard Spark ML and ML pipeline API mechanisms in order to select the features, so the columns of the data frame that I want to train a machine learning model on, and I'm also selecting and setting up the machine learning algorithm. I'm using k-means, which is a classification machine learning algorithm, and I'm configuring it to train 5 different groups of data. Now I'm stitching all of these data preparation and training steps together as a so-called pipeline using this new pipeline construct. Now I can finally run this entire pipeline at once using Spark, and I'm using as input this partition data frame that I explicitly partitioned into 10 different partitions. This runs now for a while in Spark, so we can now switch to the dashDB web console and see what is running inside Spark. We open Monitor Workloads, where we find a Spark monitoring pane. There we see that we have Spark workload running currently for 2 users, so we select the one that we used for our notebook. And this opens the standard Spark monitoring UI. There we open the application named IBM Spark kernel, which is the backend kernel application for notebooks. And here we can now watch the progress of our Spark workload in the Spark cluster. And as you can see, there are a lot of jobs that are running in parallelity of 10 or 20, which is exactly the parallelity due to our partition data frame. When the training is done, we can now look at the model results, for instance numerically, as we can see it here. So these are the so-called centers of the groups, or so-called clusters, that the model has trained. But I'm now going to use also this nice Brunel visualization library that we can use with Scala and Spark notebooks in order to plot our results. And I'm not just plotting the resulting model, the so-called cluster centers as dots, but I'm also plotting a heat map of the input data set, so you can visually compare the quality of the model with the input data. And finally, for the sake of this little demo here, I'm applying this model as in a batch prediction run to the input data again, and I'm defining here with this construct, this is write construct, where the data should be written. So it's another table, a target table, and Spark will run the prediction and write the data there. And now we can also switch over to the monitoring page again in Spark to see what's happening, and we will see that there's now a writing job running in Spark. Now let me contrast this by doing the same in a partition system for dashDB. In this other system, when we look at the dashDB web console and to the monitoring workload page, we can see that this is a partition system. There are these members that are shown here. There are in fact 24 members in this specific system that I'm using right now. In the notebook, I'm now using the raw data frame that we retrieved with the IDAX data source, and I'm not doing any explicit partitioning myself. When we now run this model training and we look at the Spark monitoring, we can see there is still going on a lot of things in parallel because of the data frame that we use is already partitioned, and it's exactly partitioned across those database partitions that exist. So we can see all of these jobs run in parallel in Spark because of the database partitioning that is inherited. And not only that, the IDAX data source also takes care that the tasks in Spark are actually executed in a co-located way with the according database partition that basically feeds the data for a certain data frame partition. And when we now run the batch prediction in this partition database dashDB system, then we can see it's also done in parallel just because it is a partition system and the IDAX data source takes care of doing that. Now when we are happy with our machine learning flow, we can now prepare that this entire machine learning pipeline can be deployed into dashDB as an application, a machine learning application that you can call through an API. In order to do this, we just say file download as Scala. This will download the Scala source file, which will be the basis for compiling a deployed application. In order to see how to do that and deploy applications in general, please watch the deployment tutorial of this video series. Thank you very much for your attention.